Exactly. For those of you who didn't think it was a good idea, I don't know what's wrong with you. Okay, our first goal today is to learn to sketch angles in standard position. It's super easy. Are you ready to go? Okay, every angle has two sides. It has an initial side. The initial side always goes on the x-axis on the right-hand side. Every angle also has a terminal side. That is the ending point of the rotation of the angle. We draw a little arc to show our rotation. What's different about the next one? It's negative. What does that mean? Opposite direction. So is it the red arc or the blue arc that I want to use? The blue arc, because the red arc would be a positive rotation. And so you can see why showing those arcs is important, because it shows the rotation that you had. Are we clear? What's different about letter C? Okay, so it is a radian measurement. Why do we know it's a radian measurement and not a degree measurement? Because it does not have a degree sign on it. Because I could sketch an angle of pi degrees, couldn't I? That would be a very thin angle, but I could still draw that angle pi degrees. But that's the difference between pi radians. That's 180 degrees. This is 3.14 degrees. So the way that we show the difference is using this degree symbol right there, okay? So 4 pi over 3. Now, some of you did the conversion in your brain. You came up with how much? 240, because pi over 3 is 60, and 4 of those is 240, so good for you. But if you didn't know that, you can also think of this as 1 whole pi. Is 4/3 pi more than 1 pi or less than 1 pi? It's more than 1. Is it more than 2 pi or less than 2 pi? Now, because 4/3 pi would be like, or 2 pi would be, say, 6 pi over 3, right? Okay? So, which would make this like 4.5 pi over 3, right? Something like that. So 4 pi over 3 is going to be between which two quadrants? I'm sorry, which quadrant is it going to lie in? 3, yes, third quadrant. Yep. Okay, what's different about D? Is it, well, it's got to be your degree or radian. Which one is it? It's radians. It does not have a degree symbol, so it's in radians. Now, most people, when they see this, they're like, well, it's going to be a really small angle. No, not really. It's going to be a very large angle in the opposite direction, and we're going to show you why. Remember, this is 0 radians, and then this is pi radians, or 3.14 radians, right? Oh, just got the head shake from student back. They're like, this is disgusting. It's all right. It's okay. Vomit inducing. Okay, wow, holy cow. TMI. All right. So 6.28 radians would be all the way around, right? So it'll be less than all the way around, correct? Well, half of 3.14 is 1.57. So pi over 2 is 1.57. And 3 pi over 2 would be 4.71. And so I try to keep those numbers in my brain to help me understand that, you know, you can represent it in terms of pi or as a decimal. So not all radians are expressed as in terms of pi. Some of them are decimals. So suppose it was positive 4.6. Which quadrant would I end up in? The third quadrant, right about here, right? So if it was negative 4.6, which quadrant will I end up in? The second quadrant. Very good. Once again, you guys can see that it's not that necessarily everything in trigonometry is super complicated. It's just, it's new, isn't it? And that's why being here is so important, unless you are preoccupied by other things that are more important. Okay? Which is impossible because nothing's more important. Okay, very good. Thank you. Okay, last one. What's different about this one? Oh my goodness. Anyway, here we go. All right, so 420 degrees, which I will change that in the problem next year. So we'll go like 450 or something, or 480 or whatever. Okay, so I got 420 degrees. So how is that different from all the other ones we've done? It's more. How much more than 360 is it? So the deal is that I really sketch a 60-degree angle. But how do you think I show that I travel around more than once? Yeah, you make a swirly, okay? Yeah. It's called a swirly. It's a mathematical term. Make the swirly. That's 420 degrees. Everybody got it? Okay, we're going to pause the video. You're going to practice quick sketching some of these, and then we're going to get on to our second topic. All right, here we go. Take out the coterminal angle worksheet. Notice that the last angle we talked about, 420 degrees, was in the same position as 60 degrees. And so those are coterminal. Coterminal angles are angles whose terminal sides are in the same position. So you're on the worksheet right now that I just handed out to you, okay? We're going to do a couple of your problems together, and this is the second part of our learning, is coterminal angles. So if you take any given angle, we'll say 110 degrees, okay? Everybody good with 110? Angles whose terminal sides are in the same position. I'm going to draw two more angles. They are going to be coterminal, meaning they are going to have a terminal side in the exact same position. We'll show that they are different by our swirly symbol that we will use. Thank you, Jessica. New mathematical term, swirly. Okay, so I'm going to do another one that's positive, and I'm going to create another positive one by, anybody know another positive angle that would be coterminal? I'm going to add 360, and I get 470. So 470 degrees is coterminal with 110 degrees. I just go around more than once. Yes, no? So for the green one, I'm going to do I'm going to make that negative. I'm going to go around backwards. And close, not 250, but negative 250. So we took 110 and we subtracted 360. Now, it does happen to be that you could take the angle 110 and you could add to it 360k. And k meaning any integer. So -2, +5, 10, and add that to 110, and it would be then coterminal. So there are infinite number of answers for coterminal angles. I'm just asking you today to provide one that's positive and the one that's negative with the one that's given. So let's look at number 5, negative 140 degrees. I'm first going to sketch negative 140. I'm going to do a positive one and a negative one. So negative 140 is going to put me in which quadrant? Third quadrant. So if I add 360 to this, 360 and negative 140, that's going to make 220 degrees. So I still have the same location, I just rotate in the other direction, 220 degrees. That would be positive. Now I'll do one that's negative. I'll take a negative 140 and I'll add to that a negative 360. And I come up with negative 500 degrees. So we know it has the same position because it's coterminal. Just instead of going around part of the way, we go around more than once. We have negative 500 degrees. Everybody okay with that example? If the angle is expressed in degrees, please put your final answer in degrees. If the angle is expressed in radians, like number 8, please leave your final answer in radians. Now, some of you are extremely intelligent. You already know 5 pi over 4 is how many degrees? 225. Very good. So I'm going to leave it as 5 pi over 4 because I should make sure I express it in radians and not degrees. That is my rotation. If I want to find another one that's positive, what would I add to it? 360, which is 2 pi. So I take 5 pi over 4 and I add to it 2 pi, or 8 pi over 4. So that's just 2 pi with a common denominator of 4. Yes? So 5 pi over 4 plus 8 pi over 4. 13 pi over 4. And you notice that will be around more than once. Now I want to do one that's negative. 5 pi over 4 minus 8 pi over 4, and I would get, very good, negative 3 pi over 4. And that's it. There we go.